freeze this. So we're looking at partial fractions. Okay? So, Ruben, partial fractions can be written when the numerator is a smaller polynomial than the denominator. Okay? So, if you look at that, the numerator is just a polynomial power 1, and the denominator would polynomial power 2. So if a numerator is a smaller polynomial than the denominator, then we can write it as partial fractions. Okay? A partial fraction is when the denominator can also be written as a multiplication, as in 2-factored brackets, as a quadratic, or if it's a cubic, 3-factored brackets, or a quartic, 4-factored brackets. But it only really works when there's a multiplication going on as well. Okay? The rule states that if you've got px plus q over the double bracket ax plus b, cx plus d, then you can rewrite that as a over ax plus b over 6 plus d. Because if you think about when you add algebraic fractions, the first step in adding algebraic fractions is to multiply your denominators together. So it's basically reversing an adding of algebraic fractions. Okay? Because you multiply your denominators together, you'd then multiply a by cx plus d, you'd then multiply b by ax plus b, and then it would form together to make your px plus q, if you were to add fractions. So it's reversing this. So, to put into an actual question context, basically, if you've got 2x minus 13 over 2x plus 1 equals, 2x plus 1x minus 3, that can be rewritten as something, which you don't know, over 2x plus 1, plus something over x minus 3. Is that okay? Right, the purpose of partial fractions is to then work out what a and b are. Okay? So looking at this equation that we've got here, is there anything that anyone can actually just identify that you can do so that we can start progressing through this question? What could we get potentially rid of? Make it equal to 0. There will be some kind of making it equal to 0. What do you mean by the brackets? Sorry? What's that? Yeah, I know you're looking ahead in the thing, but what have they done there? Yeah, they've kind of cross multiply. Basically, they've got rid of a fraction. Okay? They've got rid of the 2x plus 1 x minus 3 bit by multiplying through by 2x plus 1 x minus 3. And when you do that, obviously the left-hand side just becomes our 2x minus 13, because we've multiplied through by the denominator, which means it just disappears. The reason we get the x minus 3 with the a is because when we times each of these two terms here by this thing, a different thing cancels out. So when we multiply a over 2x plus 1 by this, the 2x plus 1 will cancel out with the 2x plus 1, leaving us with just x minus 3 in front of our a, or a in front of our x minus 3. I think they like to write a in front. Okay? Plus b with what's left over from the other one, which is the 2x plus 1. Okay? It looks like all they've done is shift the 2x plus 1 in front of the b and the x minus 3 in front of the a, but technically it's because they've multiplied through by this term here, and that's cancelled out with things. Okay, that's what's actually happening. So once you get to here, you want to find what x is. Okay, and the only way to find out what x is by substitution. Okay, so you look at these two brackets, x minus 3 and the x plus 1, and you think, well, actually, how could I get rid of my term involving a or my term involving b? So how could we get our term involving a to disappear? You make the bracket equal 0, okay? So if I make x minus 3 equal 0, how can I do that? What can I substitute in there? X is equal to 3. So if I'm going to investigate x is equal to 3, what that's going to give me is 2 lots of 3 minus 13 is equal to a 3 minus 3, which is 0, so my a term is going to completely disappear, plus my b, 2 lots of 3 plus 1, okay, which gives me 6 minus 13 is minus 7, is equal to no a's plus 7b. Okay, so b is equal to minus 1. Cool. So we've got one of our letters now. We've got b is equal to minus 1. Now we need to think of how we can get our a term. So what can we substitute in to get rid of our b? What are we going to substitute into there so that the b term disappears? Negative a half, or minus 0.5. Okay. Basically, you just say 2x plus 1 is equal to 0, and then solve that. So x is equal to minus a half, or minus 0.5. So x is equal to minus 0.5. So we've got 2 lots of negative 0.5. Minus 13 is equal to a lots of minus 0.5 minus 3. Plus b lots of 2 lots of negative 0.5 plus 1. And I would recommend showing this for working out, even with a substitution into b. You know the b is going to cancel out. That's the whole point of this. But showing that substitution is showing your full working out. And Cambridge got a bit weird a couple of years ago and they like to see more working out. I don't know if they would be real picky about that specific thing, but it's not worth running the risk of them like complaining at you. So negative 1 minus 13 is equal to minus 3.5a, okay, plus 0b. That becomes minus 14 is equal to minus 3.5a, so a is equal to 4. Okay, so we've got a and b. We wanted to write our actual solution as partial fractions. So what we say is that 2x minus 13 over 2x plus 1 x minus 3 is equal to, so my a, which is 4 over 2x plus 1, so 4 over 2x plus 1, I don't need the bracket, sorry, 2x plus 1, and my b, which is minus 1, so minus 1 over x minus 3. Okay? Is that okay? So basically, split it up to get the denominators, the split denominator, and then times through by the denominator of the original fraction, and then substitute in x values to eliminate our a's and b's and c's when we have c's. Okay, because we can have multiple terms. Okay, hopefully, well, there definitely will be an example like that at some point. Okay, there are different cases though. Okay, this is the partial fraction term where you've got a numerator such as px plus q. It could be a quadratic, by the way. That could be a quadratic on top over a quadratic on the bottom. If it was a quadratic on top and bottom, there's something we have to do first, and we'll look at that in a second. But if it was a quadratic over cubic, just do what we've just done. Things will eventually cancel out, potentially. I think generally they like it just as a linear on top, but they can be quadratics, and we'll look at that in a second. At least I think they can be quadratics. Yeah, they can be. Yeah, cool. So yeah, the next thing, what happens when you've got a repeated root on the bottom? Okay, it's a bit different. Okay, if you've got a repeated root, what you have to consider is just the bracket itself, the x plus b, and then you also have to consider the squared version of a bracket. Okay, off the top of my head, I can't remember exactly why it splits up like this, but you just have to learn these rules basically. So if you've got a repeated root, you have to consider the fact that there is a term over the linear version plus a term over the squared version. Okay, so let's see what that looks like in practice. So that means that this is equal to a over x minus 4 plus b over x minus 4 squared. Okay, we're going to do the same thing again, where we multiply through by x minus 4 squared. And that's going to give us 2x minus 11 is equal to a lots of x minus 4 plus b. Okay, because the x minus 4 squared will cancel out with the other x minus 4 squared. Okay, once we're here, obviously there's no way of getting rid of b currently because there's no x term attached to it, so we can't substitute in an x value to get rid of b. So we're just going to substitute in an x value to get rid of the a. So what's the x value that we're going to substitute in? 4. Okay, yeah. So 2 lots of 4 minus 11 is equal to a lots of 4 minus 4 plus b, which gives us minus 3 is equal to b. Okay. Well, we've got b, but there's no way of me substituting in an x value to get rid of b. So what else could I do now? Yeah, you know what b is. B is minus 3. So when you now consider the equation, you just need to make b equal minus 3.
Can you do that for the other one as well?
Yeah, you could have done it in the last one. So once I found my b here at minus 1, I could have had the minus 1 in there, and you still have to substitute in a value, and that's what we're going to see now, is that you still actually have to put in like a value of x to find out what a would be. So I found b is minus 3. So I'm going to substitute in the next value because you need to get rid of one of the terms. You've got x's and a's. You can't solve for a's if you've got x's still. So you need to give a random value of x, because x can be any value because it's a variable. A, B, and C are constants, so they can't be any value. Okay, they are going to be a specific value, whereas x can be any value. Okay, so we're going to substitute in the x value. The general rule of thumb is just substitute in x equals 0 if you're substituting in a random one, because it makes x terms disappear. So we're going to put in x equals 0, but we're also going to include b is equal to minus 3 into the equation. So we've got 2 lots of 0 minus 11 is equal to a lots of 0 minus 4 minus 3. Okay, that gives us negative 11 is equal to minus 4a minus 3, which is negative 8 is minus 4a, so a is equal to 2. So random x value, okay, random x value, and b that's been calculated. Okay, I could have chosen 1. I could have chosen the x value 1. It would have still given me a equals 2. I could have chosen any x value other than x equals 4, because x equals 4 would have cancelled out the a term. I could have chosen any x value and it would have always given me a is equal to 2, because a is a constant. A doesn't change based upon x. X can be any value, but a is always 2. Okay? Any questions about that? No? All right, so final step is just to write the partial fraction. So 2x minus 11 over x minus 4 squared is equal to 2 over x minus 4 minus, what's my b? 3 minus 3 over x minus 4 squared. Cool? Any questions on that? So it's just rules. So if there's a squared, you need a term involving ax plus b and the x plus b squared. Cool? Right. It doesn't stop there. I'm not going to do this full one. Maybe I will. I don't know how much time we got. We got about 12 minutes. Right, so this one here, we've got a quadratic on top. What have we got on the bottom? Yeah, but polynomial power 3, so it's a cubic. Quadratic on top, cubic on bottom. So our numerator is still smaller than our denominator, so we can still do partial fractions. That will become important in a second. Okay, so when we split up this fraction, we've got 3 different terms that we're going to need to write. We need a term involving a over our first bracket, the x minus 2. we're going to need a b over just the inside of our square bracket, which is 2x plus 3. And you're going to need a c involving our 2x plus 3 squared. Okay, so if you've got a square, you need the individual term and the squared term. Okay, that's what we did on the last one. Basically, it's combining this identity here, okay, where if you've got 3 brackets on bottom, you need 3 different terms, okay, with this identity here where if you've got a squared bracket, you need 2 different terms, okay. So you've got 1 term from this, and from this you've got 2 terms, okay. Now we need to multiply through by our numerator, so we're going to multiply through by this. So I'm just going to write it to one side. We're going to times through by x minus 2, 2x plus 3 squared. And this is where you actually have to start kind of thinking, oh, what's going to be my a, b, and c? Or what bracket's going to be attached to my a, b, and c? So I've got 1 minus 9x minus 8x squared on my left-hand side. When I multiply through by x minus 2, 2x plus 3 squared, on my a term, the x minus 2 is going to cancel, but it's going to leave me with what? 2x plus 3 squared. Okay. When I multiply my b term, which is just a 2x plus 3, what's that going to leave me with there? X minus 2 and 2x plus 3, because it only cancels out with one of the 2x plus 3s of a 2x plus 3 squared. And then my c term is going to just be x minus 2, because 2x plus 3 squared will cancel out with 2x plus 3 squared. Okay, so slight difference. Now on my b term, I've got 2 brackets. Okay, and when I substitute a value in to cancel out my a term, because I can substitute an x value into here, it'll cancel this out. When I cancel that out, it's also going to cancel this out, because the x value that cancels this will make this also 0, which cancels this out completely. Okay, and when I substitute in a value for c, it's also going to cancel out my b term, because the thing that cancels this out makes this become 0, which cancels that out. Okay, so when I sub in a, when I sub in to get rid of c, it's also going to cancel out my b. So what I need to do is find out what a is, I need to find out what c is, okay, and then using my a and c value, I'll substitute in a random x value to find my b term. Okay, that's what's going to happen here. So let's start off with cancelling out c, because I can see c is quite an easy one. So I'm just going to get rid of c, which is using the value x is equal to 2. Okay, so that's going to give me 1 minus 9 lots of 2 minus 8 lots of 2 squared is equal to a 2 lots of 2 plus 3 squared plus b 2 minus 2, 2 lots of 2 plus 3, which is just going to be 0, plus c 2 minus 2, which is also going to be 0. Okay, so these things disappear. Nice, easy. Okay, leaving me with 1 minus 18 minus 32. So that's minus 39, is it? 49? Minus 49? I can't even see where the question is in the book to even check that. Yeah, I'm on 170. Yeah, minus 49. Cool. Minus 49 is equal to 49a. That's nice. Leaving me with a is equal to minus 1. Okay. I'm now going to cancel out the a term, which will cancel out my b term. So I'm going to use x is equal to, well, 2x plus 3 must equal 0. 2x plus 3 equals 0. So x is equal to minus 3 over 2. So minus 1.5. Okay, so 1 minus 9 lots of minus 1.5 minus 8 lots of minus 1.5 squared is equal to a lots of 2 lots of minus 1.5 plus 3 squared plus b minus 1.5 minus 2. 2 lots of minus 1.5 plus 3 plus c lots of minus 1.5 minus 2. Alright, cool. It's just so much like just writing down numbers. cancels out, they both disappear. Leaving me with, on my left hand side, use a calculator, guys. But minus 7 over 2 is equal to minus 3.5c, which gives me c is equal to 1. Okay? We now have a, we now have c. Any value we substitute into x will into the b1. Anything that will cancel out a or c that we sub in will cancel out our b term. So now we need to sub in a random value for b, for the random value of x, and use our a and our c as we know what those values are to calculate it. What value of x are we going to substitute in? 0. Always sub in 0 if you don't know it. So we're going to do x is equal to 0. We're going to use a is equal to negative 1. And we're going to use c is equal to positive 1 in our equation here, which is 1 minus 9x minus 8x squared. So 1 minus 9 lots of 0 minus 8 lots of 0 squared is equal to my a, which is just in front of 2x plus 3 squared. So minus 1 lots of 2 lots of 0 plus 3 squared. Okay, plus b. I don't know b. 0 minus 2 times 2 lots of 0 plus 3. 2 lots of 0 plus 3. Plus c, which is 1, plus 1 lot of, I think that's just x minus 2, so 0 minus 2. Type it all in. 1 minus 0 is 1. Okay. Minus 1 times 3 squared, which is 9, is minus 9. Okay. Cool. Yeah. Plus b, which is it plus? Yeah, minus 2 times 3, which is 6. Yep. So minus 6, b. Cool. And then minus 2. Okay. In the book, they've just said let ax equals 0, and they got the equation 1 equals 9a minus 6b minus 2c, and then they substituted in that a and c value into that. Okay, which is fine. You can do that, or you can do it all in one go, like I did. Doesn't really matter. Okay, you're right. Back, guys. So you get 12 is equal to minus 6b, so b is equal to minus 2. Okay, guys. Final answer: 1 minus 9x minus 8x squared over x minus 2, 2x plus 3 squared is equal to my a, which is minus 1 over x minus 2, plus my b term, which is minus 2 over just 2x plus 3, plus my c term, which is 1 over 2x plus 3 squared. Yeah, cool. That's it. Easy, right? Yeah. That's not it, by the way, guys. There's one more, but there's only 3 minutes left, and there's not enough time for me to do it. Okay? I'll do the last thing on, it's called case 3 in the book. Wednesday, when we next have a lesson. Basically, that will be all of partial fractions, once I do that. And then we can do binomial expansion, which is the last thing in algebra. Yeah. Cool. So